Good afternoon. Assalamualaikum. Each session for each class, I will record as well in Teams. Okay, so later on, I will upload the link to the recording video in CN. Okay, as of now, I will not invite you into the Teams yet because not necessary as of now. So I will just record from the Teams and share with you the link. Okay, so the session now is recorded already. Okay. Okay, we start with chapter 1B. I have uploaded the notes in CN. Can you retrieve all the notes? You can see, some of them is from previous, all of them is from previous semester. During current semester, while we're going through the classes, sometimes I add new things. So after the class, I will update the new lecture slides. Okay. Basically, the general, the basic things is similar. Okay, as we know, mathematical model. We know that in general, it has the dependent variables and also independent variables. Is it okay if I don't use the slideshow? Yeah, because I find it much more easier to handle. Okay, so we have dependent variables, which it depends to few of these independence variables, parameters. Okay, for example, let's say in a process, let's say A plus B equals to C. So the C is the dependent things. It depends to the A and B condition. Okay. So A plus B equals to C. This C is the dependent variables, dependent things, because it depends to this A and B condition, parameters, volume, component, composition, everything. Okay, concentration. Okay, so C here is representing the dependent variables. A and B is the independent variables. Okay, you need to understand that first because most of the time we will use equations which relates x, fx. Okay, the dependent variable usually reflects the behavior of state of the system, whereby the independent are usually like dimension, time, space, which we cannot control. Okay, and then the parameters are reflective of the system properties of composition. Like what is the concentration, what is the density, okay? Then forcing function are the external influences acting upon the system. Forcing function. External influences here, for example, in a closed system, perhaps the temperature, the outside temperature will affect the closed system temperature. Okay, because of the heat transfer. Somehow they are correlated. Okay. Can you see now, student at the back? Is it clear? Do you need me to switch off the light or not? That's right. That's better. Okay, so this is a system where we have few of variables, parameters, which later on will affect this outlet. the dependent variables. Okay, so these are the some of the equation where it involve the dependent and independent. So for example, ideal gas law. You are familiar already with this equation, right? Ideal gas law. So the P of the system will be influenced by the mole, temperature, and also the gas constant. So all of these will affect the pressure of the system, right? Okay, similar to those equations. Now, some example in engineering problem analysis where we have here a storage tank contains liquid at depth Y. Okay, this is the depth Y. Where Y equals to 0 when the tank is half full. Okay, so meaning that it starts from here when the tank is half full. Y equals to 0. Okay, so Y0 here meaning that it already have some volume of the liquid inside. Okay, liquid is withdrawn at constant flow rate of Q. Okay, this is the outlet. Okay, the term effluent. Those are the terms. Outlet, effluent. Okay, the contents are resupplied at this rate. Okay, these are the feed rate. Okay, feed, inlet, influent. So these are the terms that represents a stream going into the system. Okay, this one, another one is product. So when you see the product stream, it means the outlet of the system. Okay, so it has Q in, Q out. Okay, in, out. And so in, out. Okay, so those are the terms. Now, what it want to analyze? They want to analyze the dynamic behavior of the liquid height, which is the Y, from T equals to 0 to 5 days. Meaning that's from day 0 to day 5. They want to analyze how is the behavior of the liquid height, whether it is constantly increasing or it has decreasing, or what is the trend. Okay. Now, from this system, the fixed parameter is the surface area of the tank and also the Q. Q here is the outlet, Q. Okay, 400 meter cube per day. The inlet is at sinusoidal rate. Okay, so now from day 0 to day 5. By applying the mass conservation law to the system, we can write the equation as this. So we can see the change in volume, delta V, is equals to inflow, which is the Q in minus Q out. Okay, then from that general equation, you will see okay, we know that the V over here is equal to A multiplied by the Y. Area multiplied by height. That is the volume equation. Okay, that one general one. So change in time, dv over dt equals to q in minus q out. Okay, up to here, you know how to generate the equation, to derive the equation. Now, then, after that, we simplify the equation. Since the area constant, so we simplify to this. Then further simplify, you will get this final equation. dy over dt. Okay, here no more the volume. Here is focusing on the y, the height. Okay. Now this is the equation that you will use. The final equation that you will use. Okay, up to that. You can stop me anytime if you don't understand. Then, from calculus last time, do you take calculus? No. Calculus? No. Statistic? This semester? Okay. What else? Okay, from the differentiation equation, if you want to get into y equation, what you need to do? Integration, right? So by integration, you will get this final equation. This one, using the integration. Okay, I will not teach you how to integrate. Analytically, by integration, this is the solution. Okay. This one, you can check the integration appendix lah. Okay, I will not teach in details on this one. Okay, by the equation that you get from the integration, you calculate based on your input. Here is from day 0 to day 5. The t, the one that you want to analyze. Okay, so from day 0, how to get the y is using this equation. Okay, this one using analytical solution by doing integration. Why? By doing integration. Okay, now this is the value that you get from this y equation. Now, what I want to highlight over here, okay, not this one yet. Okay, this one just now from the value that you get, so you will get this kind of curve since it is sinusoidal. Okay, now here is the trend of the y from day 0 to day 5 using analytical solution, not yet the numerical. Okay, now numerically, we know that just now the equation dy dt. Okay, this equation basically is the equation to calculate the slope. If you have linear line, to calculate the slope, you will have dy over dx, correct? y2 minus y1 over x2 minus x1, right? Okay, so basically that is similar approach. From here, we have x-axis is t. So from ti to ti plus 1. In our case here, t0 to t5. Okay, so we want to know the trend over here, delta y. So delta y over delta t equivalent to the slope. So from this equation, we know that yt1, y2 lah, okay, y2 minus y1, x2 minus x1. Okay, using this equation, we extend. Okay, we extend the equation. Just now, from the system, we get the final equation up to here, right? dy dt. Okay. Using numerical solution, this dy dt, you replace with this. See here, we don't do any integration. Okay, dy dt replace with this. The right hand side remain the same. Okay, this side remain. Now, we want to find y from day 0 to day 5. So this is the one will be our dependent. Okay, so this y ti plus 1 should be on the left side. So the rest bring to the right side. Then you rearrange, you will get this final equation. Okay. Okay, 2 minutes for you to digest. Let me know if you're still not clear. I can repeat, no issue. Okay, you notice the equation is different now from the analytical method and numerical method. Okay, the equation are different. Wait, let me copy the initial equation. Okay, so this one, analytical equation, analytical solution. This one is numerical solution. Okay, the equations are different. The values later on will be different as well. Okay, but somehow it will follow the same trend. Yeah. Now, starting from the day 0, you can compute using the equation you derive from the numerical method just now. Plug in the 0. Wait, I copy this one. Yeah, so replace the t equals to 0. At t0, y at t0 is 0. Okay, so t0. Then this one, how we get this? Huh? Come again? X1. Step size of 0.5 per day. Okay. Okay. Just now, the statement earlier, it doesn't mention the step size. Just now, it mentioned from T0 to 5 only, correct? There is no statement on the step size. Okay, step size here is required for you to proceed with your calculation. If it is not given, you should ask what is the value of the step size. Or Otherwise, you can assume on your own. Okay. Now, step size here is 0.5. Step size here means the difference. So from 0, 0.5, 1, 1.5, up to 5. Okay. Now, when here, this one is fixed. Step size. Okay, so at 0, t equals to 0. This is your y. Using numerical method. Yeah. Next, from 0.5 to 1, practice the similar. Just plug in the equation. Okay, now, here, this is your y at t I. It's like this. At t0, you get this 0.1667. Okay, so for t0.5, this one will be 0.5, 0.5. Sorry, this one is the y value. So this y value is this. Okay, so plug in this here. That's why you get over here. Then 0.5, t equals 0.5. This one is fixed, the step size. Okay, so this one is y t 0.5. Okay, so you now get this value. Okay, this is the using numerical value. This one using the math analysis just now. Okay, you see at t0, y equals to 0. At t0.5, is it correct? T0, it is this point, right? Sorry? I not get you. YTI. Okay, this one, y at t0. This one should start from 0. Y, wait, let me, t0. Oh, okay, got it. Y at t0. Y at ti plus 1. The height at t, oh, sorry. This one not at t0. This one is y at t equals to 0.5. Sorry, my bad. Okay, so 0, y equals to 0. Y at t 0.5 is this one. Sorry. Okay, Moving forward, this one is, okay, this one is y at t 0.5. So this one is at t1. Okay, y t1. So now y ti plus 1. So y 0, sorry. The next point lah, t 0.5. So this one using for t1 using the previous value. To find the new value, you use the previous value. Okay. The t here is depending on the value of the t, then you'll get this figure. Okay. So you will get this trend until day 5. Notice the difference between numerical and the analytical solution just now. The figures is different. Okay, but the trend is the same. Now, how do you calculate to get the y value over here? Let's say you have the various of input over here. How do you calculate the y? You do it, you press it again one by one, or you set equation? How you usually do? You get my question? Using your calculator, let's say just now you calculate 0.5, you get this value, right? Then to calculate when t equals to 1, so you press again the equation, or you set the equation inside your calculator? Huh? Press again one by one. That's how you do? Okay, it is easier for you to set the equation in your calculator. So you just input the next calculation, you just input 1, then press equal. Do you know not that technique? Not yet. Okay, I'll teach you. I'm using this calculator, FX570MS. Okay. Now, the important part is the equation over here. Yeah, this equation. I highlight first. Okay, this is the equation that we want to use. Remember the 0.5, the step size is already fixed. Okay, step size is fixed. Now you press, the unknown will be the x. Okay. Now we press, this is your unknown, right? So do it, x. How to press x? No, alpha x. Alpha x, get it? Then plus, in bracket, sine power 2. Sine power 2. Okay, how do you do the sine power 2 over here? Sine in bracket 2 or sine power 2? How do you do? Okay, let's try. Wait, let me try first. Because just now I tried with the previous equation. Wait, let me try to press first. Which one is working? Sorry, wait. What do you use? Sine square. Then multiply by x. Then wait. It is confusing when it involves sine power 2. Because sine, if you set sine x, then only you power 2, different with sine power x. Yeah. Okay, let's use this one. Later we try an error because I don't remember how to set the sine power 2x in the calculator. Okay, we try this one using this equation because just now I tried using this equation. Okay, this one for the unknown we set as x. So here in bracket 0.5 multiply alpha x. Okay, close bracket minus open bracket 1/4 sine 2t. T there replaced by the x. Sine 2 alpha x. Okay, then minus 1/3 alpha x. Okay, set up that equation first. Then how to calculate? You press the calculate CALC over here. Press calculate. Okay, it will appear as x. What is the x value, right? It will appear at this. So you just press, let's say 0.5. Then equal. Do you get the value? Get Then for the t equals to 1, just press again the calculate. Press calculate, then you input 1. Then press equal. You will get this value. So you don't need to press to repeat the value again. Just set the equation over there. And this value, make sure your calculator is in radian mode. If in degree mode, you'll get different value. Okay, the X, you can also use alpha A, B, or C, any letter. Okay, because that one is the unknown. Once you set the equation, just press CALC, calculate. Then input your value, press equal. But if the advanced version, you just can set equation on top. Directly put the equation on top, I think. Okay. So you cannot get it. Later on, I will share the link of the YouTube video, how to set the equation and the press, how to press. Okay. Okay. Can I proceed? Now, just now for the sine power 2, later I will update again how to press. Okay. Here it compare from the numerical method and also the analytical method. The trend is there, but you can see there are difference. Okay, there are difference. How to know which one is the correct one? That one you need to have the true value. Okay, in our case, here we don't have true value. Here is just to compare the difference between analytical procedure and numerical procedure. Okay, you can see there the trend is the same. The value is different. Okay. Okay, for type of error, we have two types of error, truncation and round off. Okay, that one, before we go to that, before we go to that, I want to try one example with you. Okay, let us try one example. Okay, the equation given here, dy dx. This is the equation that you will need to use. Okay, from the question, identify the equation, identify the range, identify the starting point. Okay, this is the starting point. X0, Y0, starting point. Then what is the range that you need to do? From X0 to X5. Okay, then what is the step size? 1. Step size is 1. Okay, those are the important infos that you need to extract out first. Equation, starting point, the range, and the step size. Okay, because the range you need to know when you should stop. So you need the range. Step size, you need to know how big is your scale. The question asks to plot the graph of y versus x. Equation given here is dy dx. Okay, how to find the y? We don't do integration. Okay, using numerical method. Okay, now using numerical method. We know dy over dx is equals to di plus 1 minus yi. X over xi plus 1 minus xi. I plus 1 here means the next point. Okay, the next point equals to the right hand side. Okay, now rearrange in order for you to get the equation of y. So y, I plus 1 Okay, so this equation is important. The one that you will use to calculate your y value. Okay, up to there? Can anyone need me to repeat? Clear? From dy dx equation, we find y equation. Okay. Now after that, can do in table form. Okay, easier. Okay, I copy again the equation that we get just now. Okay, we know the range is from x0 to x5. Step size equals to 1. Step size, in other words, in letter form is h. Okay, step size. Okay, then you generate the table, much more easier. X, Y. So your step size, sorry, starting point is 0. From the range is from x0 to 5 with step size equals to 1. Okay, then calculate your y using the equation over here. So for x equals to 1, y, plug in the x here, put 1. So here also 1, 1. This one is fixed, equals to 1. So replace the x value in the equation, then you will get what is your y value. Okay, try it. Let's see if you can get the correct figure. This equation, if you set in the calculator, you need to use the variables. Because y is one variable, x is one variable. Okay, so the value you should be getting around this figure. 25. You get what? 20. If you set in the equation in your calculator, you should have two unknowns, two parameters, two variables, y and also the x. If you set only x, that's why your answer will be different. Okay, when you press calculate, you input what is your y, then it will ask what is your x. Okay, the y here, it changed according to your value. If x equals to 2, so your yi will be the previous value. Okay. Now, how the graph looks like? Roughly, then you plot the graph, y, x. Roughly plot. You get curve, something like that. it's easier if you know how to set the equation. Okay, the calculation will be faster. Okay, okay. I need to move to error, type of error. Just a few more minutes. We just intro to the error. Okay, source of error. Basically, from the Taylor series or any type of series. Okay, how to using the Taylor series, I will explain you the different type of error. Okay. Now this one I won't wait. I won't explain details on the Taylor series. I want to focus on the error. Okay, in error, in numerical methods, numerical error arises from the use of approximation to represent the exact mathematical operation. Okay, this one from Taylor series, you will have until n order, okay, in general. And then the summary of the equation, you will have this kind of thing. Okay, this one we call as the remainder. Remainder here inclusive the error value. Okay, include the truncation error, which result when approximations are used to represent the exact, and also the round off error. Yeah. We have truncation error and round off error. Okay, truncation error means from the series over here, you truncate. What does it mean by truncate? Truncate. Cut. Okay. So from the series over here, let's say you only use the equation only the first term up to here. So first term will be only e exponent x equals to 1. But when you use the following terms, let's say then you move to use the second term. So you cut up to here. Then your equation will be 1 plus x. If you include this, then your equation will expand. And your value will be much more closer to the exact value. Yeah. Later I show. Okay, so truncation error means when you truncate the equation, you will have the error. Using the first term, let's say you use the first term only, compare when using these 3 terms until the third terms, your value will be different. That one is truncation error. Now the true error, true percent relative error means from the true value. From the equation, you will know what is your true value. The one either from the calculation or given to you. Okay, that one is true value. Then to calculate the true error, the true value minus the approximate value. I explain first, later we do exercise. Okay. Then true value minus approximate value over the true value. So this is the true error. Symbol, this symbol. Okay, ET. whereby another one is the approximate percent relative error, EA, which it use only the approximate value, not the true value. Okay. So we have ET, true error, EA, approximate value. This one is the most common error that you will use. Okay, true error. Approximate error. Approximate error means when you have, let's say, y just now, you have y2, y1, y2, y3. So approximate error is between the values over here. Current, which is y2. Okay, let's say EA for these two. Current is y2 minus y1 over y2. Then you have your error. Multiply by 100. That one is approximate, using the approximation value. Okay. But if true error, let's say you want to find the true error, ET, using the true value given, you must have a value for true value. So the true value, the true error over here will be your true value minus, let's say between these two again, for y1. True value minus y1, approximate value over true value. Then you will get your error. One is ET, using the true value. Approximate between the values that you calculated. Okay. Another one is, what is the term over here? Pre-specified percent tolerance, ES. Pre-specified error, meaning that ES here is using this equation. It has its own equation, ES. 0.5 multiply 10 power 2 minus n. Okay, n over here is the significant figures. It depends to the significant figures. What is significant figures? Let's say this one, 2.78128. Significant figures is 6. The whole number. Okay. What is the decimal point? How many decimal point here? 5. Okay. Decimal point 5, significant figures 6. Okay. So now, let's say you are given the condition to find the EA lower than the ES. So ES is depend to the significant figures. Let's say the question mentioned significant figures equals to 4. Okay. Okay, let's say the n equals to 4. So plug in the 4 into the equation. 10 power 2 minus 4. You will get the ES is 0.5. Okay. So here will be 0.5 multiply 10 power negative 2. Negative 2, right? So is it correct? 0.5. So your ES is 0.5. Now you should calculate your EA below 0.5. So your EA should be below 0.5. Meaning that you should calculate the EA until 0, let's say 0.5. let's say you get the highest will be 0.49, then only you can stop. If you calculate the EA, you get 0.7. You need to proceed your calculation until you get lower than 0.5. Okay, so ES over here is the condition when you should stop your calculation of error. Okay, this one is intro first. Later, when you do the exercise, then you can understand further. Okay. Again, the ES is based on this equation and based on the significant figures. Sometimes the question gives you the significant figures. Then you calculate the ES. Sometimes the question directly gives you the ES value. Okay. Okay, here from this Taylor series, add terms one at a time to the series until EA lower than ES. So first iteration, you use only the first term. Second iteration, you use until the second one, and so on. Okay, so third iteration, use until this, until you get the EA lower than the ES. In this statement, it doesn't mention what is the ES. Okay, this one is for example. Now, from the iterative methods, according to the term that you use, first term, second term, until lower than ES. So you can see the difference. Okay. Now we try. Not enough time already. You have class after this? Hungry already? Stop or proceed? Okay. Okay, so we stop up to here. Tomorrow we will proceed with this example. You can look through first from the slide so that you can understand tomorrow. Okay, wait, before you leave, I need to update the attendance. I will share the link